Hello, everybody. This is Mr. Tam back with another episode of Secondary for Math, this time exclusively for students who are taking the science option path. So we're going to continue with a little bit of trig, and last time you saw that we were working on sine law. This time we're going to work on cosine law. And what is the purpose of cosine law? Well, here's the thing. For the most part, you have triangles that don't have a 90-degree angle in it, so you're satisfied with using the sine law to actually solve for any either missing angle or missing side. But here's the issue that could potentially come up. What if you were given a situation where, let's say I draw a some kind of non right angle triangle here, where it looks like this. Ooh, that's a little too wide for my liking. I don't like that. I'll try this again. Let's have it at this angle, this length, and we're going to connect together this end right here. So we have A on one side, B on another, and C as a third angle. So we're going to label this side as 10. We're going to label this side as, or this angle here as 34 degrees. Oops. Let's make sure that you guys, clear for you guys, 34 degrees. And let's label this side to be 7. So the problem with sine law is that it requires that you know two sides, and one of the angles that's given has to be across from one of the sides given. So in this case, it either has to be given as angle B or angle C, but neither of which are given. So I'm interested actually in finding the length of side A. So we're a bit stuck here. What's also important to notice is that the two sides that are given, 10 and 7, essentially trap the angle 34 between them, kind of like a sandwich would trap the insides of it. So we can call this, the easiest way to recognize that you need to use cosine law is essentially you see the angle being sandwiched in between two sides. So what does the cosine law look like? Well, if we're using, or if we're looking for side A, this is what it looks like. A squared, which is the side that we're missing, is equal to B squared plus C squared. You're saying, sir, it looks awfully like Pythagoras, except we have to subtract from this 2 times BC, which is being multiplied, and you multiply this by cos, or cosine, of the angle that's given, in this case, angle A. And this, of course, applies for every single side that you're given. You just have to, let's say, for example, you switch the A and the B. Well, you would have to switch the A and the B everywhere. So let's try to solve side A. So in this case, A squared is equal to B, which is 7 squared. Okay, and I always put my substitutions inside brackets, not to make a mistake with signs, even though it doesn't really come into play in this case. Here I have C, which is 10 squared, minus 2 times 7 times 10 cos of angle 34. So what I have here is A squared. And if I were to solve all of this, okay, first this would become 49 plus 100 minus 2 times 7, which is 14, times 10, which is 140, cos of 34. After applying the math to all of this, we find that A squared is indeed equal to 32.93. So we just simply have to take a square root, and we end up with our final side being approximately 5.74. So what it really comes down to is proper labeling and making sure that you plug the numbers in to the right location. So my side A in this case would be 5.74. So let's attack another example where this time I am missing the angle. So how do I see when I need to use cosine law is when I see the following. Let me just draw it underneath here where, oh, actually, you know what? I'm just going to erase this, just give myself a little more room because this does require more steps or a lengthier set of steps. So what if I am missing my angle? So let's say I'm given this triangle right here, shorter side like this, and longest side like this, where I'm now given 25, 32, and 37. This being A, B, and C, and I'm looking for my missing angle A. So again, it comes back to A squared is equal to B squared plus C squared minus 2BC cos of A. So you're basically missing angle A. So before we plug in the numbers, let's try to isolate angle cos of A. So I essentially start by moving B squared and C squared over. So I end up with A squared minus B squared minus C squared. And all this, of course, is equal to negative BC cos of A. I'm going to now divide both sides by negative 2BC. Divide both sides by negative 2BC. And cos of A is what I'm left with. And on this side, of course, I have A squared minus B squared minus C squared over negative 2BC. And to solve for an angle like we've done in the past, you essentially take cos to the minus 1 of A, much like I'm going to take cos to the minus 1 of all of this. So I end up with A is equal to cos to the minus 1 of A squared minus B squared minus C squared all over negative 2BC, close bracket. So now that that's isolated, I can now substitute the numbers I have and solve for my missing angle. So it's essentially cos to the minus 1 of open bracket, let's say 25 is my side A, minus 32 squared minus 37 squared. And your numerator should end up being a negative value anyways, because you're going to divide by negative 2 times the length of two sides, in this case, B and C, which happens to be 32 and 37. And I take cos to the minus 1 of that. This ends up being cos to the minus 1 of 0.74662 is equal to A. And my angle A is approximately, well, let's do approximately 41.7 degrees, which looks fairly accurate to the drawing. So that in a nutshell are the two varieties to cosine law. This is Mr. Tan with another episode, and until next time, stay safe. I hope you and your families are doing well. And until next time, au revoir, arrivederci, bye-bye.